You hear me?
Hi, Shunyan. Yes,
Good,
I
good.
can hear you.
Okay, all right, great.
How are
All
you?
right, good, good. Just had a walk, a lunch, and a walk. The
Oh, okay. Nice.
combination. Yeah.
It's
So how
great.
have you been?
I've been good. How have you been?
Okay, good, good, good. All right, Herman, can you hear us?
Hello.
Okay, yeah,
Hello, sir.
okay, yeah. So thanks, Herman, for joining. All right, so Victory,
Well,
we just had a sync yesterday,
Oh,
so I understand,
yeah.
why can't I hear you?
a kind of
Oh, that's why.
short time, yeah. But
No, that's fine.
please update, yeah, please
Um,
update your current progress. All right, yeah.
so a lot of
Go ahead.
things I did, I sort of wrote them on paper, but I did write some. I'll try to explain them as and sorry, let me just share my screen. So there's that. Um, so all of this is sort of random all over the place. So I'm gonna try my best to put everything together. So
Okay.
one of the things we talked about yesterday, I think you talked about Grady's um nodes, Grady's algorithm. It looks like that's the same as Dijkstra's algorithm.
Okay.
Um,
Okay.
yeah, and there were quite a few different approaches, but I think you were right. It was only the Grady algorithm that allowed for sort of keeping the information from the previous node. So it's not necessarily I don't know how much information it keeps in terms of the detailed data, but it sort of remembers the last position. So in a s- in a s- in a scenario where we have nodes separated by meters, it sort of remembers where the last position was in a
Okay.
positional format now. Let
Yeah.
me just start from here.
Okay.
So
All right.
this is like a basic. I think this is basic computer system structure. Um, but the idea was we have our physical layer, then whatever medium we choose to use, maybe Raspberry Pi, for example, and we have the data link, which is Ethernet or Wi-Fi or whatever the case may be. But it's not the network layer. That's where we sort of have our routing. I think that's where the algorithms sort of come in. So if you notice on one side you have node one, and the other side we have node two. So this is sort of the basic idea. I think this is what we agreed on from the beginning, where we have node one communicating with node two through like a basic UDP because it's pretty fast and straightforward. And yeah, there's data might be lost here and there, but more or less accurate in terms of data transfer. Um, the idea now is just to follow this pattern, sort of going forward in terms of how each node communicates with each other. So it is at this layer that the Verona overlay now sort of comes in play, or should I say the routing, the algorithms kind of come in play. Now I sort of found the website that allowed like to generate a region. So this is just
Oh,
basic, um, basic region. Under the assumption that I'm gonna use a farmland as an example now. This is a farm region, and you have all these tiny robots at the dot, and the idea is you want to sort of um send information from A to B. So I want you to like picture the dots looking something like that. I don't know if you can see that, where each node, maybe each node is the distance between each node is maybe separated by by meters, like distance, right?
okay.
Okay.
Um,
There's a distance.
yeah. So the idea is in how do you sort of send data from, say, from A, which is the big black formation, to B. And so what I learned about Dijestra's algorithm, the idea is to find the shortest possible path from one position to the next, right? So it sort of computes everything. When I mean computes, I'm going to try to explain this. It's say we want to go from 0 to 8. It sort of computes from 0 to 1, 0 to 2, 0 to 7. I hope I understood that right. Sort of computes everything in sort of a table format. And basically it evaluates the shortest distance, and then based on after evaluating everything, that it picks the best route, which is sort of different from the other algorithms. I think the other ones, I can't remember their names now, but those ones basically just move from one point to the other without necessarily evaluating the whole system entirely. Sorry, I took some notes here. So one of the I think questions we had was, so how what's the word? How can this support if help pops up? Um, there's only way I can seem to think of. Please, if you have better ideas, please let me know. Is that each node has the ability to publish and to be a publisher and a subscriber. So the idea is each node can publish data and each node can subscribe to. And then if they say 8 needs a specific information, and one of these, that's I think one of the things we talked about was sort of building this for a specific application first, because I think it would make things easier. So say it's in a farm where basically you have 1,000 robots that do the exact same thing. I'm not talking about robots that do different things now. In a case where the robots do the exact same thing, it would it's in fact I don't think it even necessarily needs to have like a pair or super pair sort of scenario. Everything can simply be pairs, and the idea is say node 8 needs information, but it doesn't have the information, so it queries the shortest one. I mean, it sort of queries everything, and when the information is, I mean, it's like I ask 7 for the information. If 7 does not have it, it checks 6. If 6, until they get to the one that has the information. And then there's the algorithm, the routing algorithm that sort of figures out what the shortest path is, and then sends, or should I say publishes the information to the subscriber or whomever requested the information. So at this point, like in a scenario like this, the information requested could possibly be a what do you call it? Position, for example, position of the robot. Maybe there needs to be some transfer of service or goods. That's just a random example. One thing I noticed, I think, in a paper, I think you suggested one Vorocast paper. Let me see if I can find it. Just sorry. No. Okay, can sorry. It's, I find it. But in the Vorocast paper, it talked about how it sort of created 2 AN layers. One is like, it sort of illustrated it as squares and another as a triangle. And the idea was, so from that, I sort of got this idea that it could be such that half of the systems are sort of like primarily publishers and another half primarily subscribers. But again, like it's not really clear because let me see, if I can find. Okay, sorry. It's easier when I can see. Shut. Nope. It's fine. No, I can't. Anyways, so in terms of the coding or what the software looks like, I tried to play around with, but then I think it's always better if I build it from scratch. This was just something from the internet. The idea was to sort of find the shortest path for this algorithm using Python. I just used very simple for that image, and this is basically what it looks like. But then again, it's easier to, it sort of gets easier when it's like a simple problem I develop myself from scratch, and then to try to evaluate the shortest distance. I don't know if you can see this part.
Okay, yeah.
That basically when you run it,
Victor,
Yeah.
can I maybe ask some question?
yeah,
Okay, so right now I think what's being presented is shortest path, right? And you also talk
Yeah.
about how they just shot. The approach probably is also distributed, right?
Yeah.
Okay. So how does this fit into the I guess the problem we're trying to address? Yeah, because I mean
Oh.
this is like how you do the actual shortest path, right? But
Yeah.
so I think the first question actually to answer would be how are we? What is the overall idea? Okay, for us to support decentralized spatial communication, right?
Okay.
I mean that is kind of like the first question, right? So
Yeah.
and obviously, I mean possibly the shortest path is part of the solution, okay, or our design. But
Yeah.
I guess my question is, how do you see this being fit into what we're trying to address? Yeah,
Okay.
right,
I'll see. I'll try to answer that.
right, right,
So
right.
in
Yeah,
terms
okay,
of
go ahead. Yeah,
now routing, right? Just basic transferring simple information, say Boolean, for example, from one point to the from point A to point B. Should I call it an area of interest now? In our case, I think we talked about how one of the things we want to do is establish spatial communication, right? A sort of a form of centralized communication where the information is not stored in one, not how do I put it? It's not stored in one central position. It's evenly
right,
distributed. So the idea is in an area of interest, or let's say in a web of nodes, the information is evenly distributed, or should I say the spatial data is evenly distributed across all these nodes. And now at this point, we want to say we are looking for, I think it's usually easier, I think, when I use like a practical explanation.
yeah. Sure. Go ahead.
So
Yeah, like
let me
you can use a
say,
real example. Yeah,
let's say position of let's say packaging robot Amazon factory. You have 1,000 of them in one place, but you want them to always, you don't want them to crash into each other. So
okay.
one of the key information in that scenario is to know the exact location of each node at any given time. Right.
So, but each
Um,
node, okay. So the robots will be publishing that information themselves. So
yeah.
yeah. So they'll be every now and again sending out a message saying this is what my location is.
Yes.
Yeah. Okay.
Yes, exactly that. So it's like they keep publishing the information, right? But instead of sending it, because the centralized option is everything goes to one big server, and all the computation sort of happens. You know, it's like how do let me say cost. The cost, for example, in a centralized scenario would be way too expensive because now we're using the internet. It's sort of in an IoT scenario, we're using the internet now, and for cloud connections and stuff like that. Those are that's computing costs that accumulate over a period of time. So in a case where each of these robots have their own sort of server, or they are their own server, and they are also their own client. The idea is they are connected in such a way that there's almost like a real-time intercommunication between all the nodes, right? So that's where I think I remember seeing a video of Shinyun's Voronoi overlay, where the Voronoi region keeps moving, right? It's almost like it's the regions are sort of defined based on the movement of the nodes. That makes sense. It's like a real-time movement of how the nodes. So in a case, so the idea now is, okay, what's the location of A or robot B? And if robot A is 2 meters away from me, I don't want to go past a certain location or region. Sorry. I don't know if that makes sense, but to know that there needs to be a sort of almost immediate update, a real-time update of that information,
Okay.
that data.
So in my mind, Victory. So okay. So to me, what the spatial routing is about is that you have let's say a Voronoi network, and you have a bunch of nodes there, and all the nodes are connected to their neighbors, right? And now what you have is you have some kind of and all these nodes are basically they can route packets. Okay. So
Yes.
now some application, let's say the application associated with node 2 or whatever, says, I have a packet with a specific, and I want to send this packet to a specific spatial location, right? Now it gives
Yes.
that packet to node 2 and says, please forward it, or please please send it along so that it reaches that spatial location. So in my mind, the question is then, okay, so what must node 2 do? So what meta information must because you can think about the packet as having a payload, and then you've got some metadata, right? Like what is the destination location. You might even have what the source destination is, but anyway.
Yep.
But then the question is, okay, so what is the metadata which is necessary? What is the forwarding algorithm or the routing algorithm which says, okay, what must node 2 do to send that information to the correct spatial location? So how does it? So let's say node 2 is connected. So you've got node 2 over there. It's connected to node 1, 8, 5, and 3. So the question is, how does node 2 decide to which of these nodes does it forward to? Will it take does it know what the spatial locations is of all the other nodes? Will it and then basically compare that to the destination location, and then somehow make some kind of a decision? See, that's the type of question. That's what I mean with the spatial routing algorithm. Okay, because that just means that you have something with a spatial location, and now how do you get it there? And once you have something like that, now you can use something like spatial publish subscribe to actually say, okay, but I'm publishing something. How do I use this underlying spatial routing algorithm to get it to where I want it to go? But you wanted to comment.
Okay. So what I had in mind, so instead of say, I think what you said was something like, okay, say there was node 1, and then it goes to node 2 and then node 2 decides. So what I had in mind, I mean, it's at least based on what I understood from the Dijkstra's algorithm. The idea was node 1 wants to say communicate to node 4.
Yeah.
So
Well,
the
okay. So
routing path. Sorry.
So Dijkstra's algorithm assumes complete knowledge. So it assumes that
Yes, exactly.
you have complete knowledge about the network. So, but in a Voronoi system such as this, node 1 is only aware of 2, 8, 7, and 0 because that's the only neighbors it has. So it doesn't even know that node 4 exists. It only knows about 2, 8, 7, and 0.
Okay.
So,
So
either what you need to do is either node 1 needs to gather information about the whole network, but that means all nodes need to gather information about the whole network the whole time,
okay,
which is a bit of a problem because then you can work out the full routing algorithm. But the problem with that is then if you do that and the network changes somehow, then you might have worked out a route and then halfway between the packet being, traveling there, the network changed and now you have a problem. So basically each time a node receives a packet, that node itself must make a decision on what's the best way of sending this forward so that it actually reaches its destination. So that's basically how, if you think about IP routing, or even or TCP IP routing, it's basically the same. When you send something into the internet, the computer sending it, the host, it doesn't know the complete route. All it knows is what's the next node or the next host that I need to send the packet to, or and then that has information about the next host says, okay, but I have a routing table which says if you want to send it to that area over there, then this is the next guy you just need to send it along. So in that sense, IP routing is also, or TCP IP routing is also completely, it's decentralized. So my question to you is, how do we do spatial routing without having complete knowledge of the network?
Okay. So basically, there's sort of, it looks, I think that was, I was thinking of it, but I didn't think of the gap in between the VON and the routing algorithms.
So that makes sense what I said, Shilin.
Yes,
yes.
Oh, sorry. Yeah.
Yep. Herman's right. And it's true that spatial routing is important and it will likely be needed at the layer below a spatial pops up. Okay.
Yes.
Okay.
Spatial pops up probably is a function, a feature that is built on top of some sort of spatial routing. Okay.
Okay.
Yeah, and it's also important to note, and this is what I tried to explain yesterday, is that a lot of the algorithms you might find, like that Dijkstra, other, well, you have to note whether they require global knowledge. Okay.
Okay.
Which means that the nodes, the positions of all the nodes, versus whether you could just rely on a local, a more more local knowledge. And if you were to make this really decentralized, you have to think about how you can achieve the same effect, but with just local knowledge at each node. You see? I mean, this is essentially a very important feature or function for a decentralized system. Okay? Yeah, you cannot assume that you have global knowledge. So
yeah,
that's that also makes a lot of the global approach. You will have to see how you can adjust or reapply, right, to adapt to a decentralized environment, or otherwise use something like greedy routing, right?
Yeah.
Okay.
Yeah, so right. to me, Victory, the spatial routing, the only thing that the spatial routing needs to do is it gets a packet, it has a destination spatial location where it needs to deliver, and the only job of the spatial routing is knowing where must I forward this to next so that it's so that it reaches its destination, and do it in a decentralized manner. To me, the spatial pub sub, which sits on top of that, that's more about managing things like to whom, how do I, having lists of hosts that have subscribed to certain areas, or hosts that
groups
are publishing to certain areas. So that's more about, oh, I want to publish to a certain area. Great. So then that must be translated to, okay, but how must this packet information be distributed so that everyone that has subscribed to that area actually receives a copy of the message? And that kind of, the spatial pub sub assumes that there is a layer below it, that if you give it a packet with a spatial location, that routing layer will make certain it gets to that spatial location.
Okay. So it looks like there will definitely be a need for some of super peer that maybe has some sort of universal knowledge, or at least some level of universal knowledge.
Possibly for the spatial pub sub, I think. I'm not sure if you need a super peer for the spatial routing. But so are you saying you need a super peer for the spatial routing, or for the spatial publish
For the
subscribe?
spatial routing now, for the spatial routing, because I'm trying to think of how to sort of creating the bridge, and how to have some form of universal knowledge, or perhaps I would have to think of look into other types of routing that does not require universal knowledge.
So if you look at Dijkstra, then you're going to need central knowledge. But what I do suggest is you you search for decentralized shortest distance path algorithms, and see if there's any out there. Because if you can find a decentralized shortest distance path algorithm, then that would already be a building block for making a decentralized. Then you can do routing without needing global knowledge.
Okay. Right. And greedy routing is one of them. Okay.
Yes.
It's actually the one used by BOM, Borrowing Overlay Network. There may be others, so you can, welcome to do a survey yourself, to see which one might be better. But I like to point out the real work that in your work or design could be on how you actually build a spatial pub sub on top of that.
Yes.
Okay.
Yeah.
Yeah. I think that's actually the main body. How are you going to create a design that does that? And okay, so a couple of feedbacks. One is that I don't know if you've read the VSO paper or the VAST state paper previously.
The previous ones you sent earlier, the ones I had like from months ago.
Yeah. Anyway, these two papers already have some design of how to support spatial pub sub, on top of BOM.
Okay, I think I have.
So so you might want to have a look and probably try to figure out, because this is already existing work. So I think probably you should have a knowledge or mastery over these existing work, and then see basically whether you agree with the design or you might want to improve it, right?
Yeah.
Okay, in some way, and then obviously is to implement the design, and you can verify. Okay. Right now we're at the design stage. So what I would suggest is, have a look at those papers, okay, and then see if the design makes sense to you, okay, or if it's actually missing something, and whether you can come up with a better design. Okay, you can build on that, or you can come up with something new. Both are fine. Okay. All right. So I think maybe next Tuesday, if you can present the, I guess the initial design ideas or the design, that would be great. Okay.
All right.
And
Yes.
yeah,
So-
and
Because I think
okay.
this is all the, yeah, I think the fact that you've got this now and you're putting the Voronoi there, you're putting the nodes there. I think this is a very good way of, embedding yourself in the problem now and to figure out, okay, but what exactly is it that you need in order to do this? Here is
Okay.
the VSO paper, I think, which is on ResearchGate.
VSO paper, I think it's right. Yeah, right now it's probably have to do a search. Okay.
Oh, I've
Think-
yeah. So that's a ResearchGate version of it, and there is actually a VLI over there. So that should
Okay.
give you and the Varocast paper is
Oh, I
probably
have
there
this.
somewhere as well. Okay, cool.
Right.
But I'll look.
And
I'll
also
look at
vast
them
state,
again.
also the vast state papers. Yeah.
Okay. I'll do that. Thank you very
Okay.
much.
All right. Okay. So
Professor, I just wanna. Sorry, you were saying something, Shanyan?
oh no. You want to ask?
No, this is like a side question with regards to the application I got from Professor Hammond yesterday.
Oh yeah. So I mean, so you
Um,
don't need to ask Shunyun this.
Okay. All right.
Yeah,
So
yeah,
maybe
like-
that's it. Then I'll see you on Tuesday then. All right. Okay.
Yes.
Yeah.
So,
Cool. Thank you,
I'll be
Shunyun.
offline. All right. Yeah.
Thanks,
Thanks.
Shanyan.
All right. Yeah. Talk then. Yeah. Bye bye.
Professor Hammond, I just wanted to ask about the signature. Can I do digital signature, or
Yes, yeah.
should I
We
print it
all do
out and
digital.
sign?
No.
Digital
You can do
signature.
digital signature. Yeah, that's what we do as well.
And the full academic record, should I send that, or it's not relevant? I'm not really
Yes.
sure.
No. You. If you didn't study at Stellenbosch University, you will need to send a full academic record. Yeah.
That's
If
fine.
you can. But I mean, you did, doesn't that?
I will
mean,
send that.
Okay, cool.
And I do
Cool.
have a copy of it with me, yeah.
Okay, great.
And also, I don't know, should I fill this in as well?
So you can
or-
fill yours in, and then I'll fill in the rest.
Okay.
So I can fill that information in about the supervisor and the co-supervisor.
But I have filled. And yes, I wanted to be sure. I know the department is electrical and electronics. But
You
I'm
want
not
electronic.
sure.
You want electronic.
Okay.
Yeah.
I think that decentralized spatial routing or pub stuff. I don't know. It's not really. I don't think it's been defined fully yet. The proposed topic.
Okay. I see you said the qualification is BTech Mechatronics.
No, there's like three. There's.
Oh, okay. Sure. Okay, great. You had me worried there for a moment.
No. And yeah,
Okay, cool. Yeah, that'll work. Yeah.
that would work. Okay. There's no
Cool.
need to put in the name. I see there's just space for surname and.
Yeah. And then we just
should
need
I
to
also
get you a
attach?
SC.
Sorry.
So should you also attach?
The ID copy. Oh, I know you already have it, but I don't know if I should send it again.
No, the ID copy isn't necessary. No, the academic record is more the important part.
I'll send that. I'll send that now.
Cool.
Thank
Okay.
you very much.
Okay. Cheerio.
Yes. Bye.